Okay, let's take a look at this problem. I had to, because I worked it, and then I can't figure out and got the right answer, so I was happy with myself. But all right, so here's a swimmer capable of swimming at a speed of 1.03 meters per. This is your problem 52, and I'll give you a hint on problem 53 too. Can swim with a speed of 1.03 meters per second relative to the water. Starts to swim directly across a 2.2 kilometer wide river. Okay, first thing you got to do, everything's in meters per second. You got to convert that kilometers to meters. All right. However, the current is 1.18 meters per second and it carries the swimmer downstream. Got a question for you. Is there any way that swimmer could, if he pointed himself cattywampus to the current at a certain angle, is there any way at all that he could get across the river with how fast he or she can swim? He or she can only swim at 1.03 meters per second. The current's going at 1.18 meters per second. Turns against it the relative velocity. He or she is going to get carried down at 0.08 meters per second down the river. No way they can get across. This is one of the life lesson. If you're ever swimming in an ocean, or especially if you're swimming in coral reef type places, scuba diving, or snorkeling in such places like Okinawa, where I've snorkeled and scuba dived, but never scuba dived and snorkeled before. If you get caught in an undertow, or if you get caught in a current, go with it. It's much stronger than you. Just go with it. You might wind up a few miles down the shore, but you'll be alive. Anyway, so, and how far downstream will the swimmer be upon reaching the other side of the river? Okay. How long does it take to swim across the river? It's not as hard as you think. Okay? It's not as hard as you think. What do I do with it? Okay, here we go. So let's take a look at this. All right, so velocity of the swimmer with the water is 1.03. The velocity of the water with the ground is 1.18 meters per second. So dy, now look, this one is in the y direction. That never changes. There's like no acceleration working against her or anything like that. So she's going to keep going in this direction, and this is how far she's got to go. So it's a simple rate times time. Distance equals rate times time. So you can find the seconds. And then dx, how far downstream did she wind up? This is her x velocity. So it's not that hard of a problem. Now, here's what's kind of cool. Here's a cool thing. All right, so we've got a good idea on relative rates. Let's say I'm on the Starship Enterprise, though. This is just a for instance. And I am traveling at 0.75 the speed of light. All right? I'm traveling at 0.5 the speed of light. There is a friendly vessel coming this way. So the velocity, so I've got a ground observer here on the Earth. I'll be very American centric here. This is my little northern hemisphere. Got an observer here on the Earth looking at these two rocket ships. Put the ears in. It's either me or Barack Obama, one or the other. But anyway, all right, so this observer notices the velocity of the Starship Enterprise, of the Enterprise to the globe, is equal to 0.75 times c, which is c is equal to 3.0 times 10 to the 8 meters per second. All right? The velocity of this starship, of the friendly ship to the globe, this is g, of the friendly globe, I could have had it a Klingon, I could have put Klingons in there, is negative 0.8 c. What's the velocity what's the velocity of the friendly ship relative to the Enterprise? Okay, this is 0.8 C. All right, well, you just go, okay, well, F is equal to negative 0.8 C plus now when I flip-flop, you might be going, hey, wait a minute. The velocity, I need G first. So the velocity of G to E is equal to negative 0.75 C. In other words, if this is stationary, then the Earth is going in the negative direction this way. All right? Plus negative 0.75 C is equal to, so the friendly ship relative to the Enterprise is going negative 1.55 C. That's impossible. Can't go faster than the speed of light. So that means it's zipping at them. If it's impossible. Stay tuned. Next semester we'll explain how this works. It's still going to be less than C. It's going to be less than 3.0 times 10 to the negative 10 to the positive 8 meters per second. All right, enough here. That's it for relative